Any questions? Okay, second one, if it tells you that A over B equals C over D, then A over C equals B over D. Is this statement true or false? This statement is false because if you know that A over B equals to C over D, D could be 0, right? The corner case, there is a corner case that C could be 0 because C here is a numerator, not denominator. So C could be 0. If C is 0, we cannot put it in the denominator position, right? If C is 0, A over C is not defined. And therefore, A over C is not equal to B over D, right? So this statement is false. This statement is true only if A and C is not 0, right? Okay, any questions? So generally speaking, if you have a ratio A over B equals to C over D, you can have AD equals to CB, right? But it does not necessarily means A over C equals to B over D. This statement is true only if C is not 0. Okay? Any questions? Okay, I'll leave you 1 minute to think about this. Okay? All right, if you have no questions, let's see question 2. Evaluate and simplify. Okay, this is an expression that involves radicals. Square root 15 is 3 by 5, right? And by square root 5 plus 27 is 3 by 9, and 9 is a perfect square. Plus 12. 12 can be factored to 3 by 4, and 4 is a perfect square. So next, we can put these together, 3 by 5 by 5. And second term is, we can put a 3 in front, and number 3 is left within the square root. The third term is 2 times square root of 3. Okay, next, first term is, because we have 5 by 5 under a square root, so we can put 5 in front. That becomes 5 by square root of 3 plus 3 times square root of 3 plus 2 times square root 3. Okay, and then they have a common factor square root 3. So we can add these coefficients together, which gives us 10 times square root of 3. Okay. Any questions? Okay, if you have no questions, let's move to the next one. Evaluate and simplify this expression. Okay, 50 is 25 by 2, right? And 25 is a perfect square that we can put out of the square root sign. Second term is 4 times 72. 72 is 36 by 2, right? And 36 is a perfect square that we can put out of the square root sign. So the first term is 3 by 5 square root 2. Second term would be 4 by 6 times square root 2, right? So then we multiply these numbers all together, which gives us 3 by 5 by 6 by 4 by 6 by square root 2 square root of 2. Okay, and this gives us, okay, we can calculate this first. 18 times 20 times 2. Okay, then calculate this first. 36 by 20. And this gives us 720. Okay, any questions? Yeah, the reason I calculate 3 by 6 first is because if you calculate this first, this gives you 15, right? And then this gives you a 24. 15 by 24 is not very easy to calculate by brain, right? So it's better to calculate 3 by 6 first. 3 by 6 gives you 18 plus 20. This is very easy to calculate in your brain, okay? Any questions? Yeah, the takeaways here is sometimes changing the order of the multiplication can make the calculation easier. Okay, let's see the next one. Evaluate and simplify. Okay, there is a decimal under a square root. To solve questions like this, it's very common to transform the float or decimal number to ratios. Okay. It can be noted that 17.64 is 1764 over 100, right? So when you put a square root here, 100 is a perfect square, so we can put it out of the square root, right? The key point is 1764 a perfect square? Okay, to check whether this number is a perfect square, we can try to factor this number with some prime numbers. For example, it is obvious that it can be divided by 2, right? If you divide this number by 2 first, this gives us 8, 8, 2, right? And 882 can be divided by 2 again, which gives us 441, right? 441 cannot be divided by 2 again. So let's try the next prime number, which is 3. This gives us 1, 4, 7, right? 1, 4, 7, again, it can be divided by 3 because 1 plus 4 is 5. 5 plus 7 is 12. 12 can be divided by 3. So this number can be divided by 3, right? Do you know how to check a number if this number can be divided by 3? You know that, right? Okay. This number divided by 3 gives you 49. So 49 is already a perfect square. So it's not necessary to factor this number again. Okay. So we can factor this number to 2 by 2 by 3 by 3 by 49. Okay, this means one, 7, 6, 4 is 2 to the twice times 3 to the twice times 7 to the twice. Or you can rewrite it like 2 by 3 by 7 to the twice, which is 2 by 3 is 6. 6 by 7 is 42 to the twice, right? Okay, so this problem becomes square root of 1764 is square root 1764 over 100, which is ratio between these two square root. Okay, because 1764 is 42 square, right? And 100 is 10 square. I don't put the brackets here. So now we can put 42 out of the square root sign and 10 out of the square root sign, which gives us final result of 4.2. Okay, any questions? Okay, so the takeaways here is when you try to calculate square root of a decimal number, just try to transform the float number or decimal number to ratio. Okay, because it's not very easy for you to think of a square root of a decimal number. Okay, just try to transform this decimal number to a ratio of 2 integers. Okay, I'll leave you 2 minutes to think of this. Okay, do not leave any questions at home. If you have any questions, please ask here, okay? Because in your next assignment, you will meet similar problems. I'll make sure you feel comfortable with these questions, and then we can proceed. Okay, let's see the next question, which is very similar to question 4. Again, you want to calculate a cube root of a decimal number. Okay, so the intuitive way to do this is to transfer the decimal number to a ratio. Okay, it should be noted that minus 2.744 is minus 2744 over 1000, right? 1000 is 10 to 3 times, which can be canceled with this exponential. So here, the key is to check if 2744 is a cubic root of any number. So 2744, first, let's try to factor this number. Apparently, you can divide this number with a 2 first, right? This gives you 1372. 1372 can also be divided by 2, which gives you 686. 686 again can be divided by 2, gives you 343, right? 343 can be divided by 3, which gives you 1. Oh, sorry, cannot be divided by 3. Next, we can check whether this one can be divided by 5. Apparently not, because it's not ending with a 5. So next prime number would be 7. Okay, 343 divided by 7 gives you 98, right? Sorry, no, should be 49, right? And 49 can be divided by 7, which gives you a 7. So now we factor this number to 2 by 2 by 2 by 7 by 7 by 7. So 2744 is 2 to 3 times 7 to 3 times, which is 14 to 3 times, right? So next, we want to calculate the cube root of minus 2.744, which is cube root of minus 2744 over 1000, which is a ratio between these two cube root. Okay, first is minus 14 to 3 times. For denominator, 1000 is 10 to 3 times, right? Okay, now the exponent can be canceled with each other. Okay, we can cancel 3 here, cancel 3 here. Then it gives us minus 14 divided by 10, which is minus 1.4. Okay. Any questions? This is our final result. And also remember, you can always check your answer. All right, let's check the answer here. If minus 1.4 to 3 times equals to minus 2.744. Okay. So 1.4, but 1.4 is 1.96, right? And then 1.96 by 1.4. This gives us 4472. Okay, which is 2.744, which is equal to the right-hand side, right? So remember that you can always check your answer. Okay. Any questions? Okay. If you have any questions, let's see the next one. Evaluate and simplify. This is a very large integer. If you want to calculate a very large integer to some ratios, it's better to factor this large integer first. Okay, it should be noted that 9261000 is apparently 9261 by 1000, right? And 1000 can be rewritten as 10 to 3 times. And you have 3 times here. Also, you have 1/3 here. This can be canceled with each other, right? So the key point is, let's see whether we can factor this number. Okay, let's try from the smallest prime number, which is 2. Apparently, this number cannot be divided by 2. So the next prime number is 3. Okay, so this one can be divided by 3, which gives us 3087. Also, again, this number can be divided by 3, which gives us 1029. Again, this number divided by 3 gives us 343, right? Okay, 343 cannot be divided by 3 again. Okay, so next prime number is 5. This number cannot be divided by 5. So next prime number is 7. Try 7 here, which gives us 49. Okay, 49 is divisible by 7. which gives us 7. So this number can be factored to 3 multiplied by 3 multiplied by 3 by 7 by 7 by 7. That means this number is 3 to 3 times 7 to 3 times, which is 21 to 3 times, right? So 21 to 3 times here, and this one can be canceled with 1/3 here. So the next step would be this number to some ratios becomes by 10 to the 3 times. Okay, and now we know that 9261 is 21 3 times. Okay, so this is actually 210 to 3 times, right? And then this number to a ratio. And these two can be canceled with each other. Okay, this gives us 210 minus 2 times, which gives us 210 to twice over 1, right? And 210 to twice gives us 44100. So this is our final result. Okay, this is the final result. Okay, remember a to the minus b times is a to the b times as a denominator, and 1 is your numerator here. Okay. Remember this. This is very important. Of course, a cannot be 0. Okay, any questions? Okay, if you have no problems, let's see the next one. Question 7. What is the smallest positive integer n such that square root 396 n is an integer? Okay, if I ask you that if this one is an integer, this is easy, right? Because 25 is a perfect square. And how about this one? This one is also an integer because 36 is a perfect square, right? So if this one if the number under the square root is a perfect square, then you can get an integer, right? So this gives us the way to solve n here. Okay, first of all, let's factor the coefficient first. Okay, first factor the coefficient. 396. Okay, 396. Let's try to factor this by the smallest prime number, 2. This gives us 198, right? 198 can also be divided by 2, which gives us 99. Okay, 99 apparently can be divided by 9, right? This guy gives us an 11. 11 is a prime number, so no more factors there. So this number can be factored into 2 by 2 by 9 by 11. So this means square root of 396n is 2 to the square, 2 to twice times 3 to twice times 11n, right? So here, apparently, to have an integer, you will have n equals to 11. This is the smallest possible number that gives you an integer after the operation of square root, right? And also, you can check the result. If you put n equals to 11 here, the result is 2 to square by 3 to square by 11 to square, right? So this gives you 2 by 3 by 11, which is an integer, 66, right? This is the verification. Okay? Any questions? Okay, if you have no questions, let's see the next one. Question 8. For what value of m is the following equation true? Okay, 3 to the m times equals to something. If we can transform this to 3 to something, that m should be equal to the number here, right? So let's see if we can transform the right-hand side to anything. Okay, cube root of 9 is actually cube root of 3 to the twice, right? 3 to the twice, and then find the cube root, which is actually 3 to 2/3, right? Pay attention to the transformation here. This is very important. Because for any number a, or for any number x, x to a over b times gives you x to a and then b's root, right? So the first term, we successfully converted the first term to 3 to some times. The second term is square root of 27. Okay, 27 can be rewritten as 3 by 9, right? 3 by 9 is 27. And 9 is 3 to the twice. And then this 27 can be rewritten as 3 to 3 times. Okay, this can also be rewritten as 3 to 3 over 2 times, right? Again, you should be able to rewritten a radical to an exponent here. So the right-hand side is 3 to 2/3 by 3 to 3/2, which gives us 3 to the addition of this number, of these two numbers, right? So this is, to calculate this, you need to convert them to a common denominator. So this means 4 over 6 plus 9 over 6. Only in this way you can add two ratios together, okay? Remember always to change the ratios to a common denominator first. Okay, this gives you 3 to 13 over 6 times. Okay, so now you know that 3 to m times 3 to 13 over 6 times. So this gives you that apparently m is 13 over 6, right? Do you have any questions? Okay, I'll leave you 3 minutes to think about this. All right, any questions? No? Okay, let's see the next one. Question 9, simplify the following expression. Okay, there's nothing to say about this. All you need is to be patient and careful. Okay, let's try to cancel the similar terms. Okay, 3 can be canceled with 3 here, right? 2 can be canceled with the 6, and this leaves you 3. Okay. Okay, now we're done with coefficients. Now let's look at the other terms. Okay, R2 can be cancelled with this R2 twice. Okay, R to the 8 times can be cancelled with this one. And R to the twice can be cancelled with this one. This leaves you R to the twice. Okay, so the final result here is anything left, right? So what's left in the numerator is 3R to the twice. So what's left in the denominator is only a 5. Anything else is cancelled. So this is our final result, right? Okay, any questions? Okay, we can do this because this is multiplication sign, okay? If we have a addition sign, that's another story, okay? Pay attention to this. These are very different. Okay, any questions? No? Okay, let's see the next one. Simplify the following expressions. Okay, to simplify this, first step is to factor anything that is applicable. Okay, for the numerator, apparently the common factor here is 3r, right? If we put 3r in front, what's left behind in the brackets? First term, we have r two twice, right? And the next term, we have 7, only a 7, right? And do remember that you can always verify. If you verify the result here, that means expand it. Okay, first term is 3r to the 3 times minus 21r, which is the same as the numerator, right? So that means the factoring process here is correct. Okay, now let's see the denominator. The denominator is 9r to the twice. Okay, then we can cancel something here. Okay, 3 canceled with 9, which leaves us a 3 here. R canceled with R, which gives us a 3 here, right? So the final result is R twice minus 7 divided by 3R. That's the simplest form of this expression. Okay, any questions? Okay, I'll give you 2 minutes to think about it. Okay, any questions? No? Okay, let's see the next one. Question 11, factor the following expression. Okay, to factor an expression, that you need to find the common part, right? Find the common part and use the distributive law to put the common part in front. Okay, apparently for this expression, the common part is x to the twice minus 3, right? This is the common part. And then we put the common part in front of the expression. So what's left in the brackets behind? So the first term, according to the distributive law, we have 2x, right? And the second term, we have a 5, right? So after this step, it's better for you to verify. if you done it correct. Okay, if you verify it, first term times x squared minus 3 gives you 2x x2 squared minus 3, right? And according to the distributive law, the second term gives you 5x twice minus 3, right? This should be equal to the original expression. Okay, apparently these are the same expression. So that means this step is correct. Okay, now you can proceed. Okay, it should be noted that this expression can be further factored into x plus square root of 3 times x minus square root of 3, right? So this is our final result. Okay, there is a formula we could use here, which is a to twice minus b to twice is a plus b times a minus b. So according to this formula, this expression is apparently, if this is our a, this is our b. This one is x to twice minus square root 3 to twice, which gives us x to twice minus 3, right? So this is why x to twice minus 3 can be factored into this multiplication. Okay, any questions? So similarly, for an expression like x squared minus 7, we can always factor this expression into x plus square root of 7 times x minus square root of 7, right? Understand? Because here, 7 is actually square root of 7 to twice. X squared minus square root of 7 square can be factored into this multiplication. Okay, any questions? No? Okay, I'll give you 2 minutes to think about this. Okay, do you have any questions? No? Okay, let's see the next one. Factor the following expression, x to twice plus 5x plus 4. Okay, intuitively to factor this expression can be rewritten as x plus a times x plus b, right? We don't know the a and b here. If we expand this expression, this gives us x to twice minus plus a plus b x plus a b, right? If we can find two numbers that the multiplication of these two numbers equals to 4, and the sum of these two numbers equal to 5, then this expression can be factored in this way, right? So how do we find these two numbers? Okay, generally speaking, we can find these two numbers by guessing. Okay, how do we do this? The multiplication of two numbers is 4, and the sum of these two numbers is 5. Okay, so to guess these two numbers, we can factor 4. 4 can be factored to 1 by 4, right? Or it can also be factored to 2 by 2. And then we can check the sum of these two numbers to see if the sum of these two numbers is 5. Okay, 1 plus 4 is 5, so this one is correct. 2 plus 2 is only 4. This one is not correct. So the two numbers we can choose is 4 and 1, right? So for example, we can let A is 1 and B is 4. This gives us the original expression can be rewritten as x plus 1 times x plus 4, right? And if you don't believe this, or if you are not sure, you remember that you can always verify your result. Okay, to verify this, all you need to do is to expand it. X plus 1 times x plus 4. If you expand this expression, it gives you x to the twice plus 5x plus 4. And this one is the same with the original expression. That means the factoring process here is correct. All right? Okay. If you are familiar with these types of questions, there is a shortcut to find these two numbers. Okay. Note that the coefficient of x squared is 1. So we can write 1 by 1 here. Okay. And then we check this coefficient or constant. Constant is a 4. So we can write 4 as 2 by 2 or 1 by 4, right? And then we cross multiply these numbers and add these two numbers. Okay, 1 by 2 is 2 and 1 by 2 is 2. 2 plus 2 is 4. This 4 is not equal to this number. So we cannot choose this option. Okay, the next option is to factor 4 to 1 by 4, and then we cross multiply these two numbers. 1 by 4 gives us a 4. 1 by 1 gives us a 1. 1 plus 4 is 5. 5 is equal to the coefficient of 5 here. So this is the correct option. So this gives us, these are the coefficient of the terms. 1, 1 means x plus 1. 1, 4 here means x plus 4. So this method is called cross multiplication. method. Okay. I'll set you another example. For example, if we have a second question like x squared plus 2, 6 plus 8, how do you factor? Okay, note here the coefficient here is 1, so we can put 1, 1 here because 1 by 1 is 1, right? And the coefficient here is 8. 8 can be divided to 1 times 8 or 2 by 4, right? It should be noted that we want the sum of these two numbers to be the number here, right? So 1 times 8, 1 plus 8 is 9, so we cannot choose these two numbers. 2 by 4, 2 plus 4 is 6, which is equal to the number here. So we can choose 2, 4 here, right? Then we do the multiplication, cross multiplication. 1 times 4 is 4. 1 times 2 is 2. 4 plus 2 is 6, which is equal to the coefficient here. So this option is correct. And then we can rewritten the original expression to x plus 2, which corresponds to the first row, and times x plus 4, which corresponds to the second row. Okay. Any questions? Okay, I'll give you 2 minutes to think about this question. Okay, do you have any questions? All right, let's see the next one. Question 13. Write the following expression as a single fraction and simplify it to the simplest form. Okay, to rewrite the following expression, you need to find the least common denominator, right? But it's better to simplify each term before you find the common denominator, okay? So let's see if we can simplify each of the terms. Okay, for the first term, this one can be factored to a times a squared minus 1, right? And for the denominator, you can copy the denominator here. Apparently, these two can be canceled with each other, right? So the second term is 7a to the 3 times over 49a to 4 times. So this one can be canceled. This one leaves you an a here. 7 can be canceled with 49, which leaves you a 7 here. Okay, so the original expression can be rewritten as a plus 1 over 7a, right? And next, to write this expression as a single fraction, we need to find the common denominator. Common denominator is 7a, right? Okay, so for the first term, if the denominator becomes 7a, the numerator becomes a times 7a, right? The second term is 1 over 7a. Okay, you can always check back the result. 7a, 7a, if you cancel this gives you an a, which is equal to a. That means this step is correct to the previous step. Okay, so the final result is 7a as the denominator, and 7a to the twice plus 1 as numerator. This is the final result. Okay? Any questions? Okay. If no questions, let's proceed to the next one. Question 14. Write the following expression as a single fraction and simplify it to the simplest form. Okay, again, first of all, check if you can simplify any terms here. Okay, the first one can be factored to 4 here, right? And the second term, we cannot do anything about it. So this original expression is rewritten to 1 over 4z to 3 times minus 3 minus z over 2z4. Okay, for me, I don't like, usually I don't like the minus sign here. So usually I will also rewrite this expression using a plus sign. Okay, if you use a plus sign here, you have a z minus 3, right? You see why? Because minus 3, here you have a minus 3. Minus z, you have a positive z, right? So this is our expression here. And to rewrite as a single fraction, you need to find the common denominator. Okay, common denominator of 4z to 3 times and 2z to 4 times is apparently 4z 4 times, right? So if we rewrite the first term using a common denominator, 4z to 4 times, the numerator here becomes a z. And the second term, if we use common denominator here, 4 to z 4 times, numerator, we have to times it, use 2, right? Because 2 cancels 4, you gives a 2 here. Okay, so now the single fraction becomes 4 to z 4 times, z plus twice of z minus 3, right? Which gives us 4z to 4 times as the denominator, and 3z minus 6 as the numerator. Okay, this is a simplest form already, right? So this is our final result. Any questions? Okay. No? All right, let's see the next one. Last question. Okay, evaluate the following expression. Okay, to evaluate an expression like this, it should be noted that any term, the difference of any term to the previous term is always 2, right? Because 4 is 2 more than 2, 6 is 2 more than 4, 8 is 2 more than 6, 98 is 2 more than 96, and 100 is 2 more than 98, right? So the difference between two consecutive terms is equal. Okay. To calculate the expression like this, we can let the expression is x. X is the number you want, or the result you want, right? Also, you can rewrite the expression as 100 plus 98 plus 96 plus 6 plus 4 plus 2. This is also x, right? The reason we want to rewrite it this way is the sum of any two corresponding terms are equal, right? Because 2 plus 100 is 102. 4 plus 98 is also 102, right? If we denoted this as 1 and this as 2, if we add 1 and 2, we get 102 plus 102 plus 102 plus 102 plus 102 plus 102 equals to 2x, right? That means x is, we can divide each side with a 2, right? X is 51 plus 51 plus 51 plus 51 plus 51 plus 51. Okay. Now the question becomes, how many 51s are there? Okay. How many 51s are there is depending on how many terms in the original expression, right? Okay. For the original expression, it starts with a 2, 4, 6, etc. And the last term is 100. Second to last is 98. you can count the total number of terms here. Okay, total number of terms is, we can use 100 minus 2. This is a length, right? This is total length. And use this number divided by the gap. This is your total gaps, right? Total number of gaps is here. But you want to find the total number of points here, right? The total number of points is always one more than the total number of gaps. So here you need to plus 1, right? Plus 1, you get the total number of points. So the result is 50, right? You have 50 data points here. So this means there are 50 terms here. So x is 51 by 50, which gives you 2550. This is your final result. Okay? Do you understand the whole analysis process? Any questions?